The artifact in Abu Rawash with signs of processing is one of the most compelling pieces of evidence for the use of circular saws in ancient stoneworking. Let's examine it in detail and determine whether this claim holds up. Before us is a granite slab. Its surface features an arched recess with characteristic periodic scratch marks. In several areas, the processing reached a greater depth. Since the recess follows an arc, it is argued that neither a straight nor an arched saw motion could produce such a concave surface. Therefore, a circular saw with a diameter of approximately 37 feet has been proposed as the tool responsible. A trench located nearby could have served as a mounting point for this saw. In this setup, the workpiece would have had to be processed at an angle. If positioned vertically, the saw's pass could have created the required recess. However, this is not a typical solution, and rather than a saw, it would be more accurate to consider a milling cutter. Nevertheless, the same saw could not have been used to create a recess with a smaller radius. If either the saw or the workpiece were tilted, the cuts would appear at the edges before reaching the center. This is a natural consequence since tilting a circular object in projection is equivalent to compressing it vertically and transforming it into an ellipse. A cylinder's cross-section at an angle is precisely an ellipse. Thus, if a circular saw was used, the initial processing would have needed to be done at an angle, while a vertical position of the same saw could have left the desired mark in the form of a recess with a smaller radius. The tilt is also confirmed by the fact that the processing left an arched trace in two projections, both horizontal and vertical. Based on the approximate equality of the heights of the horizontal and vertical arcs, the tilt angle can be estimated at around 45 degrees. In the case of a tilt, the saw's radius should not be calculated the same way as for a vertical cut. Otherwise, it would be overestimated by a factor of 1.4 at a 45-degree angle, and by a factor of 2 at a 60-degree angle. The exact radius can be determined from the vertical cut. In any case, instead of a 47-foot diameter, the actual value would be around 30 feet depending on the tilt angle. An independent challenge is feeding the workpiece at the required angle. It is obvious that tilting the disc would be much more complicated, and the existing trench would no longer be suitable. The arched horizontal trace suggests that the block needed to be gradually lifted during processing. In that case, the final cut should be at an angle rather than vertical, as observed despite the broken edge. Let's take a closer look at the scratches, which at first glance appear systematic, but, in reality, exhibit the same characteristics as those found on other objects, intersecting and changing direction. They appear and disappear in exactly the same manner as on other artifacts, indicating a common processing principle. Notably, the depth of the scratches directly depends on the hardness ratio between the abrasive and the surface being worked. For example, quartz sand leaves almost no visible scratches, which is why corundum, or even better, diamond, is used in experiments. However, there is another approach. Wood surfaces develop grooves very similar to those observed on ancient Egyptian artifacts. In this case, the effect is not achieved by increasing the hardness of the abrasive, but by weakening the material being processed. It is also easy to notice that on the Abu Rawash slab, just like on the sarcophagus in the Cairo Museum and the sarcophagus of Khufu, the dark-colored mineral hornblende does not contain any scratches, whereas traces on feldspar and quartz are clearly visible. It is well known that in experiments involving drilling and cutting with loose abrasive, the traces pass uniformly across all minerals. The same applies when using modern power tools with diamond blades. In this case, one might assume that the surface acquired this appearance due to erosion rather than machining. However, similar surfaces are found in locations protected from erosion, such as inside the pyramid. The large size of the proposed disk is often interpreted as evidence of advanced or even impossible technology. In reality, giantism is a manifestation of an attempt to compensate for low technological capabilities. This pattern can be observed in various fields, from mechanics, where modern internal combustion engines are smaller and more powerful than their predecessors, to electronics. In the case of the examined artifact, a modern machine with Z-axis positioning capabilities would easily perform such processing. For CNC systems, this wouldn't even be a challenge. With a primitive approach, reducing the curvature would indeed require creating discs dozens of meters in diameter. A simple task would demand enormous effort, which contradicts the idea of advanced technology. Additionally, the hypothesis of sophisticated stoneworking methods is difficult to reconcile with the frequent errors and defects present. At first glance, the surfaces may appear flawless, but the correct viewing angle reveals far from perfect execution. Virtually every object shows signs of deviations in saw cuts or excessive deepening. This is also evident here, where two significant errors appear on a relatively small surface. How could they have occurred? Was the finished surface intentionally reworked in a different position just to ruin it? Moreover, the surface does not merely have a few depressions, it is incredibly uneven overall. This raises the question, how could such an irregular surface be produced using a disk with a constant radius? Taking all of the above into account, let's attempt to explain the concave nature of the processing. The search for answers must be conducted within the context of a straightforward execution, which in turn reveals aspects far more intriguing and even more mysterious than the idea of gigantic saws. First, using a template of the required shape, the surface was roughly shaped into a concave form. The processing marks in the form of scratches, including chaotically arranged ones, resulted from grinding. But how was the required radius ensured? There are several possible solutions. The first is a pendulum on a rigid suspension. A rope would be prone to stretching and deviation from the vertical plane. Instead, a log mounted on an axis with a securely fixed grinding element could be used. This would simultaneously control the radius and even out the surface. Defects in such an approach would not only be understandable, but also inevitable. In this implementation, it would be more practical to work across a certain width at once, fixing the tool perpendicular to the movement. In this case, the scratches would not represent a step of the tool, but rather the result of multiple passes, just as seen in sawing and drilling. It is important to note that in areas where the processing reached a greater depth, no individual saw cut is visible. Instead, an entire layer of stone has been removed. Achieving this with a circular saw would be difficult, as the resulting trace would be completely different. However, with pendulum-like motion, due to the wear of the grinding element and shifts in radius caused by an unstable mounting, the surface would be processed in segments of varying curvature. This is precisely what is observed in reality. Another possible implementation follows the same principle, but instead of a massive disc, only a sector of it would be used. This would result in a pendulum-based arched saw with rigid fixation. Such a motion would create a characteristic arched trace, resembling the use of a giant circular saw. However, this type of tool would not be applicable to the Abu Rawash slab. For grinding, either the workpiece or the saw would need to be continuously repositioned. Additionally, removing a stone layer in a lateral direction with a narrow saw would be inconvenient, if not impossible. Such an implementation would be better suited for cutting rather than grinding stone. The key aspect of the Abu Rawash artifact is not its shape, but the traces of manufacturing errors. From a classical perspective, this would imply that grinding was carried out for hours or even days at the wrong depth. It's a conclusion on the same level as the one drawn from the unfinished sarcophagus, cutting in the wrong direction for a whole week. A single case might suggest negligence, but multiple cases raise questions. Repetition becomes an argument in favor of a systematic trait. If complex and highly precise equipment had been used, such errors would have been impossible. But the same applies to meticulous manual labor. These kinds of mistakes simply wouldn't happen. So we need to consider different time frames. That is, such marks could not have formed through hours or days of processing, but much more quickly. This conclusion aligns with the tool marks observed at the Incamazana rock site in Peru, which we've already discussed in a separate video. A similar conclusion was drawn from the analysis of the unfinished sarcophagus. But this particular artifact reveals another peculiarity. With significant tool wear, it would have been difficult to maintain a constant radius, requiring the pendulum or working part to be lowered continually. One might think that this is precisely why the surface turned out so uneven, due to a change in radius. However, in reality, a tool wear of mere fractions of an inch could not have significantly affected the radius of the pendulum, and therefore, not the surface's shape either. Moreover, if we assume the workpiece was initially shaped using pounding, then with a template, it would have been possible to achieve a clean surface requiring only minimal leveling through polishing. For polishing, even a relatively flat stone block would have sufficed. The fact that the surface turned out so irregular suggests that there was no initial preparation, or it was minimal, and the curved shape was attempted directly. That approach only makes sense if there was an easy method to remove granite layers. The same conclusion was drawn from the unfinished sarcophagus. Sawing only makes sense if it's faster than pounding with stone hammers. And the efficiency of sawing is supported by the abundance of its traces. In the end, the Abu Rawash artifact does not prove the existence of giant circular saws, but rather that the ancient Egyptians had techniques that allowed them to remove layers of hard granite by sawing faster than by pounding. Thanks for watching. See you next time.